It's New Comic Day down here at Boom Comics in Topeka, Kansas, and I'm down here to talk about faster than light travel in the Dryden Universe. Usually I try to keep these videos to about 10 minutes, but I may go a little longer this time because I want to give people a really good understanding of the framing drive and how to use the framing drive when you're writing or creating art or doing other things in the Dryden experiment. The drive that I'm talking about is the drive that humans use in the primer, and then also you'll see this technology sometimes in the Age of Beauty, and then by the time we get to the Dark or Codex 2, this technology will have faded away and you are free to develop alternate technologies. This is a science fiction technology. We are going to take some things from actual science and then sort of blow them out of proportion and make fun of them so that we can have faster than light travel. So this is meant to sound science-y, but I want to make it very clear to the folks out there who are a little more detail oriented. This is the point at which we leave reality and start talking about how to flip back and forth between stars without violating Einstein's relativity. So having qualified myself extensively, let's talk about how faster than light travel works in the Dryden experiment. There's a moment in the sort of standard model of the Big Bang called inflation, and when inflation happens, the universe itself expands faster than the speed of light. And this doesn't violate Einstein's rule because this isn't material passing through the universe at faster than the speed of light. This is the universe itself flexing at faster than the speed of light. So for the Dryden experiment, what we assume is that the universe is actually a hyperdimensional sphere. It exists in dimensions beyond our sight, and that in those higher dimensions, the ripples from that initial inflation and from other things, supernova, black holes, things like that, are still reverberating around the sphere, and they are still doing so at faster than the speed of light. No material is moving faster than that, but the universe itself is flexing at faster than the speed of light. A graduate student at the University of Antarctica named Lakshmi Bhutta postulated that it was possible to grab a hold of those ripples and not actually ride them, but grab hold of one side of one and then the other side of one and sort of step across. And you would do that without passing through the space in between. So you wouldn't actually violate Einstein's rule that nothing can travel faster than the speed of light, but you would have stepped across a lot of space. There's sort of that famous video that shows up in movies where people are talking about wormholes and they fold a piece of paper over and poke a hole through it and say, you come out on the other side. Well, this is our version of that, okay? The universe itself is rippling and pulsing in higher dimensions, and a framing technology allows you to grab a hold of that ripple and come across on the other side of it without passing through. So our variation on the theme, okay? So in practical terms, though, framing drives are sort of self-limiting because everything in space is actually curved. So if you grab a hold of a grab a hold of a ripple, which is called grabbing the frame, and start to travel along it, you actually travel in a curved path. It's impossible to travel in a straight path. So while you can hold on to that ripple until instability knocks you off of it, in practical terms, you've got to let go of it really pretty fast, a few fractions of a second, because it's headed off in a curved direction. It's not actually going where you want to go. So forward travel in the Dryden experiment using a framing drive is actually a step this way, and then a step this way, and then a step this way, and then a step this way. So you never travel more than 1 or 2 light minutes before you drop off of the curve that you're on, reorient yourself, and grab another curve. Of course, the computer does this for you, and it happens very, very quickly. But the point of that is that it restricts the speed of the travel at faster than the speed of light to about a light year per day, so that you can continue to adjust yourself on your path. While the travel itself is almost instantaneous, you have to stop and reset yourself fairly regularly. And the reason, of course, is just to keep continuity in our universe. There was this absolutely appalling moment into darkness when Khan teleported himself directly from the headquarters in San Francisco, of Starfleet headquarters in San Francisco, to the Klingon homeworld. Well, come on, guys. You know, if I can teleport directly to the Klingon homeworld, why am I even building spaceships? Next time I get in an argument with the Klingons, I'm going to teleport them over a photon torpedo. We can't have that and still have continuity in our universe. So the faster than light travel drive is self-limiting in that way. It's gonna keep you headed in kind of off angle courses so that you have to stop and come back into conventional space and grab a new frame to jump out on. All right, so that's the general gist of it. My assumption is that most spaceships are actually running a nuclear power plant somewhere on board, a small one that operates what's called the insanity crystal, and the insanity crystal is a diamond and carbon nanotube matrix that is able to detect those ripples and grab a hold of them. They pass that frame, once they've got a hold of the edge of the ripple, to a set of waveguides that exist in a circle around the ship. And what happens is immediately when you do that, the other side of the ripple collapses and comes back to meet you at much faster than the speed of light, and you step back off. So all ships in the Primer and probably also in the Age of Beauty are noted by this large ring, and that's absolutely about branding. I want everybody who looks at a Dryden ship to immediately know that it's a Dryden ship, and that ring is the hallmark. You can build other items onto and around the ring, but that is essentially the heart of the spaceship, so that they're recognizable and branded. The other thing that you'll find is that all human-built ships have the Insanity Crystal open in the middle, and the reason why the Insanity Crystal is open in the middle is because every once in a while human ships lose hold of a frame, and when they do that, the two edges smash together, and it's a highly radioactive event. It releases a whole lot of high energy particles. So especially early in human interstellar travel in the 2300s, for example, the center of that ship is extremely dangerous, and you don't want anything close around it. Early spaceship designs will have heavily shielded areas between the Insanity Crystal and the human parts of the ship. And again, that's about making sure that we have a really identifiable spaceship that you can see. If you look out on the Dryden Author and Artist page on Facebook, you'll find a post that's got a half dozen different starship designs that folks have done for us, and they're really beautiful. Not everybody is required to have that open center like that. That's a human technology. Il Solitaire, which are human Cetacean hybrids, learn how to build insanity crystals that don't shear, and you'll find that they build right inside their organic spaceships the insanity crystal right in the middle, and then it looks like a whale on the exterior still, except it's carrying that insanity crystal around, and that's because they don't experience frame shearing. So that's what we've got. We've got a technology that runs at faster than light speed, but only at about a light year a day, and it's limited in a couple of ways. Again, to preserve continuity in the universe. The first thing that you'll find when you're dealing with the framing technology is that it's really kind of unpredictable. Beyond a distance of about a light minute, you don't know where that ship is going to appear next, and that affects a lot of things. For example, all ships have to carry some sort of reaction drive, conventional drive, in order to get around in local space. You can't just jump a minute here and a minute there and assume that you're ever going to reach your target. I have been using the phrase high density ion engine. There are ion engines that NASA uses now that are extremely efficient. The trouble is that they generate the pressure of about a sheet of paper resting on your hand, and so you have to run them for a very long time to get there. In the Dryden experiment, there's some sort of high pressure variation on that allows you to move something the size of a spaceship back and forth between a moon and a planet, or maybe between planets in a reasonable time frame. I've never really explored it. The other thing is that one of the things that I worry about is spaceships framing in right on the surface of your planet or right in the atmosphere of your planet and just destroying it, and I don't want that to happen. I don't want people to be able to teleport photon torpedoes anywhere. I think that's a bad idea. And so there's an assumption that massive bodies like planets, large asteroids, suns, black holes, flatten out those ripples in space in those higher dimensions, and that closer than a light minute or two to any significant body, anything larger than an asteroid, say, you're going to find a kind of a dead spot in space where you have to drop out of the framing drive and come on in to the planet under your conventional power, whether you're using your high density ion engines or whatever else you might want to use. And that's again, it's a continuity thing. We want starships to approach, and we want to know that they're approaching, and so we have flat spaces around. That leads to another technology that is available to humans from fairly early on. It's called a rippler. And a rippler is basically an ion, or I'm sorry, is basically a framing drive that's not being told to go anywhere. It's grabbing the ripples in space around it and letting go of them, and grabbing them and letting go of them, but not actually moving. And what happens is that anybody who's trying to ride the frames, ride the ripples in that area, will fall off of them because they're being disturbed by the rippler. It's creating irregular, erratic ripples in the universe, and that prevents folks from being able to approach somewhere that you don't want them to approach. So, for example, early in the Age of Beauty, the Cetaceans decide that they want to stop humans moving from star system to star system, and they start dropping ripplers into human space. Entire solar systems just get filled up with these ripplers, and the only way to get out of them is to crawl out of them very slowly with your ion drive, and once you get out of the range of the rippler, then you can engage your framing drive. It basically stops human expansion in space because it gives everybody plenty of time to see what the humans are doing and plenty of time to react. I assume that military installations and secure communication posts and so on and so forth also use ripplers. There's a reference in one of the early Sally Dryden stories to her needing to mask her location by dropping a rippler so that no one can follow her, and she hasn't done it. So it's assumed that the Rippler is a fairly easy to acquire technology and is used to control interstellar travel. There's a couple of other things that exist that are really necessary in order for interstellar travel to happen. There are gravity well generators that are available. They're used planet side to lift things off of planets without a lot of energy expenditure, and they're used inside of spaceships in order to counter what would otherwise be the stresses of acceleration and deceleration. And the assumed technology behind those is once again off the fiction edge of science fiction, but some fundamental particles have mass and some don't, and it's something that the folks out at CERN are exploring and interested in, why those particles behave the way they do. In our future, that's something that you can actually turn on and off. So you have sections of your ship that are subject to these quantum devices that increase or decrease the reaction, and in fact can have a negative gravitational reaction. And so your gravity well generator will reduce the effective mass of your ship so that you don't experience every time you accelerate and decelerate. The other technology that's out there that makes all of this possible is something that's called a Mobius field. And a Mobius field is a one-dimensional object. Anytime you press against a Mobius field, it returns that pressure back to you equally. And that allows for the withstanding of absolutely enormous amounts of stress. It's not infinite, of course. There's got to be some entropy in the system, and your Mobius field generators will overheat as they pick up the residual inefficiency in the system. But in terms of encountering objects in space and having them destroy your spacecraft, or being able to do atmospheric entry and so on and so forth, we sort of clean up problems like that with Mobius shields being able to withstand the pressure. You'll also find them people who are building domes in hostile environments rather than trying to build a dome that's actually capable of withstanding. You build a dome that will support Mobius field generators for you so that you can hold the atmosphere out where you want to hold it, in the atmosphere in where you want to hold it in. And so Mobius field generators clean up a lot of difficulties for us. And that's the general technologies. Now, the practical application thereof, Don Van Osdol has developed a series of ships that he calls the slipshot ships. And slipshot ships work between the planet low Earth or low orbit of a planet and the interstellar ships that can't get too close to it because of the flat space around the mass of the planet. These are light craft that use some sort of reaction drive, chemical reaction or ion engine drive, to haul things back and forth, and you need a lot of them. Most interstellar ships are not capable of landing on planets, and most of them never even approach a planet. They're going to drop out a framing drive a light minute or two away, and we're going to have slipshot ships slipshot ships. Wow, that's going to get me in a lot of trouble. Hopping back and forth between the two and carrying. Lift from surface is done with gravity well generators that will reverse the gravitational reaction of the object that you want to lift off the planet and throw it into space, where your slipshot ship can meet it and carry it back and forth. One of the other things that's true and becomes very important in long-range travel in interstellar ships is that we still can't communicate faster than the speed of light. Radio communications still travel at the speed of light, and they uh, still are limited by gas and dust and things that might interfere with them. And so what you find is you find interstellar ships are carrying what are frequently called communication ponies, and this is an extremely small, faster than light ship, little bitty guy, that is mostly just a memory stick, and you load it up with all the information that you want, and you send it hopping back to a predetermined location where somebody is waiting to see it. Space is full of these. Space is also full of secret communication bases that governments and militaries use to catch ponies and redirect them and act as communication hubs. Certainly a military craft would know the location of a lot of these and be able to communicate back to Earth or to the corporation that they work for, using secret destinations that the ponies knew to jump to that weren't well known to the public. So that's a sort of a view of how it works. We've actually had some very interesting combat written by Dan Hunt in the story Revenge, which is part of Songs of Distant Stars, which should be in print any time now, that deals with how do you hit a ship that's using a framing technology, and how do you do combat with a ship like that? And it's very interesting because you don't really. When two ships are hopping around in frame, they are going to have a difficult time getting within a minute of each other and hitting a light minute of each other, and hitting each other at those distances. So what Dan explored was the idea that as a ship approaches your star system or your planet, you have ripplers out there to force that ship out of space, out of framing space, and into conventional space so that you can shoot at it. He used some technologies that were torpedoes that are going to try to frame to where you are, which is pretty exciting but pretty hard to do. You have to have a pretty good idea of where that person is going to be. The use of ripplers in order to stop folks so that you can get close to them. The thing that I would encourage you to remember is that two ships that are a light minute apart, if they fire lasers at each other, it's going to be a minute before that laser gets there, and it's going to be another minute before the information comes back to let you know whether or not you hit your target. And so combat takes on this kind of interesting, intership combat takes on this kind of interesting perspective where it's hard to engage people. You sort of need to know where they're going to be, and once you get them there, you are going to fight them across distances that can be sort of unpredictable. You're very likely to fire your missile and frame back out and hope that he was still in frame when your missile got there. It's a really kind of an interesting environment to fight in. I invite you to explore it some more, and I definitely think that you should stop and read what Dan wrote, because he really laid it out for us very nicely. I think that that's probably a pretty good introduction to the framing technologies, definitely as they look in the primer, and then as we get into the Age of Beauty, the second age, things begin to change. You wouldn't have to have a circular ship design like that if you were good at predicting the direction that the ripple was going to come from. The reason why you have a ring-shaped ship is we don't know where the ripple is going to come from, and we let the computer decide when it detects a ripple whether or not it's close enough to the angle that we want, that we'd like to travel down it. So you might actually snag a ripple that came in from this way because you want to go that way, right? And so you're going to ride that ripple in the direction that along its leading edge as far as you can, that's still to your benefit, right? And the computer's going to make that decision for you. So you've got that ring-shaped ship that's the distinctive mark of a Dryden ship from the primer. By the time, though, that the technologies get more advanced and the European starts taking advantage of them and the citizens are using them, it could be that you got good enough at picking up ripples, or maybe we're able to detect very weak ripples, that you could only have your waveguides out at points on the front and back of the ship, and could keep yourself pointed in the way you wanted to go because you knew you were going to have ripples. I also saw a tandem ring design that probably doesn't work in the primer, but I think is a very interesting idea. What if we kept one ring priming while we were firing the other ring? Maybe we could get a faster speed that way because we could jump ring to ring or jump frame to frame very quickly, pick up a lot of different ripples very quickly like that. So once we get into the organic spaceships and we get into the Age of Beauty, I'm not so concerned about what those ships look like. I'm more concerned that they look badass than that they follow the framing technology. I see framing technology sort of sliding by the wayside. Then of course, by the time we get to the dark, we don't know what things look like, and the Codex 2 is intentionally designed to be wide open and let people just have cool looking spaceships with much looser definitions of how they work. So we're going to fall away from the framing technology as we go forward. The other faster than light travel, actually it's not faster than light travel, but the other interstellar travel that we know of that happens is that at 40,000 years in the future, the technoprey wake up from their hibernation inside of gas giant planets and they start moving around. And they use a technology that's very similar to the gravity well technology. They're able to sort of make one end of their body denser than the other and fall into their own gravity well. And the advantage to that technology, it never gets up to the speed of light, which is the disadvantage, of course. It stays in conventional space, but it gives off no energy signature whatsoever. The secret of the technoprey is just one day millions of them appear in your solar system and just descend on your planet with no warning. And traveling between the stars for them takes tens of thousands of years. They point themselves at an energy source that they detect somewhere in space and go into sleep mode and wake up thousands of years later when they arrive at the next star system over. But they are in space at all times until the Scourge come and clean them up in the dark. They are in gas giants living their life cycle. And when they do get out into space, you don't see them coming because their energy signature is so small, so dark. And so there are other ways to travel in interstellar space, even in the primer. We're just unlikely to see them because the technoprey don't come into much play until very far in our future, although they do appear sort of on accident in Alder's world, which happens in the 2400s of the primer. All right, well, I can't think of anything else that I would like to say about faster than light travel in the Dryden experiment at the moment. Certainly, if you have questions, you should check the Authors and Artists page on Facebook. And if you want to get specific with a question and approach me, the best way to get a hold of me is Dryden Experiment at yahoo.com. That's DRYDENEXPERIMENT at yahoo.com. I'm Joel. This is Boom Comics. Thanks for joining us.